of staff at Fast Metals, and we are extracting critical minerals from red mud and completely eliminating this waste. So what we have landed on is one of the biggest problems facing the metals and mining industry. Basically, to produce 1 ton of aluminum, you also have to produce 4 tons of red mud, which is a toxic byproduct. This is really the liability. Currently, there's 4 billion tons of this waste stockpiled across the earth, and there's about 200 million tons of it getting added every year. 4 billion tons of red mud contains billions of tons of iron and millions of tons of alumina, titania, and mixed rare earth oxides. This represents a $4 trillion lost metallic revenue opportunity. So we are converting these liabilities into commodity revenue. Our proprietary patented chemical process is able to extract iron, alumina, titania, and mixed rare earths from red mud. The really cool thing about our process is that we are able to de-iron the red mud, which is primarily iron, and convert that to metallic iron. What remains can then undergo known and proven extraction processes to their final product. And the super cool thing about our process is that the acid that we use in it is actually from 2 additional waste streams that are present right there at the alumina sites. So in totality, we eliminate 3 waste streams, we produce metals, and we produce no waste on our end. With all of those conditions, we're able to generate $900 a ton of revenue at a 50% margin, completely separating us from our competition. We scale locally using off-the-shelf equipment, and we don't need any extreme reaction conditions. We will abate 1.5 tons of CO2 for every 1 ton of red mud that we process. We are able to operate at $280 a ton of red mud processed, which gives us a massive margin that will allow us to operate under any macro condition. Currently, we've deployed our technology on a 20 kilogram scale using 4 samples of red mud representing 4 different regions of the globe. We've acquired our first customer through a binding revenue and pilot agreement, which also gives us access to free space and free equipment. And we validated our technology with SGS Lakefield. And finally, while we were doing all of this, Rio Tinto invested in our company through their venture arm. Looking to the future, 2028, we want to package our technology basically into a 1 ton per day mobile skid, which can then be deployed directly at the alumina refineries, where it would be co-located exactly where the waste is, and the revenue from these skids would pay back the cost to build the skids. Way into the future, we want to scale to a 50,000 ton per annum plant, which would be secured through joint ventures and offtake agreements. Our company is really based on Sumed's PhD, which he did about 8 years ago in red mud processing. And interestingly, Anthony also did his PhD in red mud processing about 15 years before Sumed. Together, they have about 3 decades of mining experience. They've scaled commercial technologies. They've operated billion-dollar facilities and been in commercial roles themselves. Our advisory includes Nick Popovich, former head of trading at Glencore, and Terry McNulty, who invented the McNulty ramp-up curve, which is the gold standard for any chemical operation. And most recently, we added Nigel Stewart to our advisory as well, who's the former CTO of Rio Tinto. Most recently, and most notably, we closed our pre-seed round, which was massively oversubscribed. The investors that we attracted through this process, we are so thrilled to work with. They bring a wealth of experience and knowledge to the table. With all of that said, winning today's prestigious award would really help to keep the momentum going behind our pilot plant and keep Fast Metals synonymous with the types of innovation coming out of Connecticut. I want to thank you all for your time, and together we can make red mud greener and profitable. Thank you.
Okay. Now we'll take some questions from our judges.
Shane, thank you for a great presentation. How sensitive are the recoveries and economics to the feedstock variability of the red mud that you guys are working on?